Hello, this video is an introduction to polar coordinates. Well, we're used to defining points in Cartesian x and y. That defines a point, x along, y up. But in some maths, it's much easier to do it using r and theta, a distance and an angle. And we use this a lot, particularly in navigation and motion and things like that. So this video is going to introduce the basic concepts. Okay. What do we need first? Well, we need a point, a pole. This is called a pole. There it is. And that's where everything's measured from. So if I've got a point, I'm going to measure the distance from that pole. Secondly, I need an initial line, which I'm going to measure all my angles from. That's the line there. Usually it's the horizontal line. Okay. So if I've got a point here, here it is, it's my point. Well, its distance we define as r. Is the distance of that point from the pole, and it's taken to be positive. We'll come back to that over and over again during this lesson. Secondly, we need the angle. Well, we're going to take the angle for that line to the point. The angle is theta. It's anti-clockwise, and it's the angle from the initial line. So there we have it. Those are our two definitions, r and theta. And we're usually working in radians, by the way. We can connect r and theta to x and y by drawing our little right angled triangle here, can't we? So x equals r cos theta and y equals r sine theta. Of course, reversing that using Pythagoras, then r as the hypotenuse is going to be the square root of x squared plus y squared. And using trig, well, tan theta is going to be y over x. So we can work backwards and forwards. One of the first things we might want to do is find the distance between 2 points, r1 theta 1 and r2 theta 2. Well, there's the vector between the 2 points. How are we going to find it? Well, if we have a look down here, we can see that we've got a scalar triangle, haven't we? We know these two side lengths are r1 and r2. I'm trying to find this distance here, but I do know the angle opposite it. That's going to be theta 2 minus theta 1. So I can simply use the cosine rule from GCSE. So d squared will equal r1 squared plus r2 squared, subtract r1, r2 times cos of the opposite angle, which is theta 2 minus theta 1. So if you need to find a distance, cosine rule. Most important thing we do in polars is create loads of curves, and they're usually written in this form here, r equals a function of theta. So let's have a look at this curve here. Used as an example, r equals 1 plus 2 cos theta. When I graph that, I get this curve here, a red curve. What I've got here is an autograph image of that, which is really useful. I'll come back to why I'm using autograph in a bit. And what I could do is I can find points on this curve. So let's do a few of those just to see something. Because what's really important is our problem we have here where r becomes negative, because I said r would have to be positive, didn't I? So if I have theta equals 0, then cos theta is 1, so r equals 3. So I've got this point here. There we go. Now if I take theta to equal pi by 2, then cos theta is 0, so r is 1. So I have this point over here. Here we go. Now if I make theta equal to pi, well, cos theta is now going to be negative 1, isn't it? Cos of pi is negative 1, so r is going to be negative 1. So I've got a problem now, haven't I? Because I said that I don't want to have negative r values. But that's that point there. Okay? So as you can see, we can have these problems when we're drawing a curve where we can have a positive r section here up to, in this case, so starting at theta equals 0 here, up to theta equals 2/3 pi, I think it is here. Then as theta increases further, I get a section here where r is negative until I come back to this point where theta will equal 4/3 pi. And at that point there was theta equals theta equals pi, wasn't it? And then as I increase my theta more, I come round back to here, and the curve joins up again when theta equals 2 pi. Okay, so that's what we've got to watch out for. negative r values. Now if you're using autograph, autograph will show any negative r values with a dotted line there. If you're using your CG50 calculator, it won't do that. They'll all look like solid lines, so you need to work it out. And also in GeoGebra, it will give you solid lines, yeah? So it's quite useful to use autograph if you can get a copy. Okay, but can you see how we can go around, tabulate our values, or use our calculator and grade our curves? It is quite important to find these points where it goes from positive to negative. So at this point here, r equals theta, r equals 0, sorry. And finding out what the angles are at that point. Well, that's easy enough because we make, if r equals 0, then 1 plus 2 cos theta must equal 0. So cos theta must equal minus a half. And we can find the solutions to that, which are theta equals 2/3 pi and 4/3 pi. And we can actually draw those tangent lines on at this point. So here's the first one. Theta equals 2/3 pi. And the second one is theta here. The green line is theta equals 4/3 pi. So those are the two tangents. Those are where the curve tangents are when r equals 0. And these are the absolute definitions of these lines. Doesn't matter what the r value here is on the blue line. The most important thing is theta must equal 2/3. And all points on that line, theta equals minus 2/3. And all points on the green line, theta equals 4/3 pi. Okay, we might be interested in finding stationary points. What are stationary points in polars? Well, they're effectively where we're maximum or minimum distances from the pole. So here's one here, and here's another there. Well, how are we going to find them? Well, we're going to set dr by d theta to 0. Let's do it in this case. So if r equals 1 plus 2 cos theta, then dr by d theta is minus 2 sine theta. I set that to 0, so sine theta must equal 0. So theta must equal 0, pi and 2 pi, 3 pi, etc. So that's 0, that's theta equals 0 and 2 pi, isn't it? And 3 pi. So I have 4 pi. This point over here is theta equals pi and 3 pi, and also negative pi. So that's one way of finding stationary points. The other one we might have to do is find vertical and horizontal tangents. So he'll be, if I look at this circle, those are my horizontals tangents, aren't they? And looking vertically, these are my vertical tangents here and here. Well, how am I going to find them? I'm going to use the chain rule. dy by dx in the chain rule is dy by d theta times d theta by dx, which I could rewrite as dy by d theta is the numerator divided by dx by d theta is the denominator. Remember, differentials are just fractions. Okay, so if I want to find my horizontal tangents, well, what do I have to do? I have to set my numerator to 0. So dy by d theta must equal 0, and I can just differentiate r sine theta and make it set it to 0. If I want my vertical tangents, well, my denominator must equal 0, so that my gradient is infinity. Excuse me, and therefore I must differentiate r cos theta and set it to 0. So let's have a look at that. Let's use my trusty curve. R equals 1 plus 2 cos theta. Well, here are my horizontal tangents to this curve. And we'll get those by setting dy by d theta to 0. Here are my vertical tangents. And we're going to get those ones by setting dx by d theta to 0. So let's just do that. Let's start with the left-hand side. dy by d theta. We're looking for here. So y equals r sine theta. Subbing in our function of r there. So I've now got that for y. Differentiate it. I get this expression here. I set it to 0. And I've got a nice quadratic in cos theta. So I've got two solutions for the values of cos theta. And that gives me 4 values for theta. So let's have a quick look. What we've done here is find the theta values. So I found the value of theta here. I found the value of theta here and here and here. You might think those are a bit odd. I've got some quite big values of theta for those, but of course the r's are negative. So the maths thinks that they're going to the left, but the negative makes them go to the right. Okay, and if I want the horizontal, so the verticals, well, again, I do x equals r. In this case, it's cos theta. Then I differentiate that expression. There we go. Set it to 0, and I find I've got I've factorized it here, and I find that therefore I've got two sets of solutions: sine theta equals 0, or the bracket equals 0, which is cos theta equals minus a quarter. And that gives me, I've got 5 solutions I've picked out here, a couple of them repeated. So I've got, so let's do that in green. I've got theta equals, that's going to be theta equals 0 or 2 pi, it could be 4 pi. You can carry on with that, can't it? Here I've got this one here, that's theta equals pi. And here I've got 2 solutions, theta angles, but they actually create the same tangent, don't they, because of symmetry. So there we have 3 tangents. So there you are. It's the summary page for you to stop the video and copy down. That's everything I think we need to know for our principles of polar coordinates. And what's the most important thing is to watch out for negative values of r. Make sure you're looking for them, making sure you're checking all your signs to make sure you found them all, and decide whether you're going to use those sections of any curves. So best of luck.